So inequalities in one triangle. Let's get this show on the road, okay? The first thing that I want us to do is a little activity. I would like you, to the best of your abilities, draw an obtuse scalene triangle. Find the largest angle and the longest side and mark them in red. Then find the smallest angle and the smallest side and mark them in blue. What do you notice? So start, guys, make sure your triangle, you draw it in black so you can identify which ones are the red and which ones are the blue. Now, what does it mean to be obtuse and scalene? Not a hypotenuse. A hypotenuse is for right triangles. John?
One angle is above 90 degrees.
Bingo. One angle has to be larger than 90, so start there. Draw a large angle. And what about scalene, Hannah? Very good. All the sides should be different lengths. I just drew an example on the board. You can copy mine or draw your own, whatever floats your boat, okay? Now, second thing it asked us was identify the longest side and the longest angle in red. Do you guys agree that this is clearly my largest angle, correct? Where's my largest side? Okay. Not the hypotenuse. We don't have hypotenuses unless it's what kind of triangle? Right triangle. But do you guys agree it would be this one over here on the right? Yeah. That's the longest side? Okay, then outline it in red. Then do the same thing. It's kind of close between those last two angles, but do you guys kind of agree this top one's a little bit smaller? Whichever one is smallest for you, just put a blue mark by that smallest angle, and then find the smallest side and outline it in blue. Okay, now, yours may be different than mine, but what do you notice? What's true about the largest angle and the largest side? John?
They touch.
They do not touch, actually. This angle does not touch that side.
Oh, wait, what? Oh, I think it's smallest side and largest side.
Juliet? What's opposite? Very good. So the largest angle and the largest side, you guys see how they're opposite each other? What about the smallest angle and the smallest side? Are they opposite each other? That is always true, okay? So that is actually our first theorem today, is that the largest angle and the largest side need to be opposite, and the smallest angle and the smallest side need to be opposite. Now, I want to take you through a little diagram, right? Why does that happen? Take a small angle. If I were to connect my fingers at the very tips, right? Do you guys agree that would be the smallest side? What happens when I enlarge my angle? What happens to that side between my fingers? It gets bigger. So the sides and the angles are all proportional, right? The largest angle across from that angle is going to be the largest side. That is the first theorem today. It's called the triangle longer side theorem. So if one side of a triangle is longer than another, then the angle opposite the longer side is larger than the angle opposite the shorter side. Okay, copy that down, and then we'll walk through an example. Okay, let's check it out for this example. So, which of the two sides that are given is longer? AB, right? AB is how long? 12. So go from 12, go to the opposite angle. What angle is opposite the 12? C. So we're going to write the measure of angle C. We don't know exactly what it is, but we know it should be larger than the angle opposite the 10. Do you guys agree? So start at the 10, go across. What angle is opposite the 10? The measure of angle B. So we're going to put the measure of angle B. The measure of angle C should be larger than the measure of angle B. Because, do you guys agree 12 is larger than 10? So any side in your triangle, if it's larger than another side, the angle opposite that side must also be larger than the angle opposite the other side. Okay? Go ahead. Okay, it also works in reverse, okay? So if you're given that angles are larger than one another, then you can conclude that the sides are bigger than one another, okay? It also works in reverse. This theorem is called the triangle larger angle theorem. The first one was triangle larger side theorem. So, given the angles in this triangle below, okay, what do we know about the sides? Which sides are going to be larger than one another? Cody? AB is going to be larger than CB. Very good, okay? Start at your larger angle, go across. That 60 is across from AB. Do you guys agree? So that AB needs to be larger than the angle of 30, which is across from CB, okay? So AB must be larger than CB. Do we know the measure of angle B? Can we figure it out?
Yes.
How? Yeah. Very good. You can add these two together and subtract it from 180, okay? Remember that because we're going to be using that a lot in this lesson, okay? So the last angle here, which would be B, would be 60 plus 30, which is 90. Take that away from 180, right? And you're going to get 90 as well. So this angle would have to be 90. Clearly, this is not drawn to scale because angle B is not a 90-degree angle, okay? But just remember that going forward, if you're ever given two angles in a triangle, you can figure out the third, knowing that all the angles in a triangle add up to 180. Okay. Now, the next theorem, which is the last theorem for today, is called the triangle inequality theorem. It says the sum of the lengths of two sides of a triangle is greater than the length of the third side. And this has to be true in order to create a triangle, okay? So, how I like to show you guys why this is a theorem is I would like you to draw three sides of a triangle, but don't actually draw a triangle. So draw one really long side, okay? Draw one semi-short side, and draw like a medium-sized side. But make sure that that long side is extremely long. Is there any way I could combine these three lines and create a triangle that is connected all the way?
No.
The answer is no. Because do you guys agree that these two pieces, even if I like put them as close together as possible, it'll never reach this piece over here? It'll never connect to the long side of the triangle? So in order to have a triangle, okay, part of the requirements is the two smallest sides need to be larger than the largest side when you add them together, okay? So the triangle inequality theorem says if you add any two sides of a triangle, it needs to be bigger than the third side. So in the triangle given on the left, if we were to add BC and AC, it would need to be larger than what side? AB, okay, so let's fill that in there. If we added AB and AC, it would need to be larger than what side? BC, very good, or CB. And then if we added AB and BC, that would need to be larger than CA or AC, okay? All three of these inequalities must be true in order for the triangle inequality theorem to be satisfied, okay? And the triangle inequality theorem is satisfied as long as you're able to draw a triangle. So any triangle has to satisfy these three requirements, okay? All right, let's do an example. So I want you, this is from the first theorem that we learned. Name the largest angle and the smallest angle. Well, which one's the largest angle? Angle C. Why? Because it's opposite what? Angle C is opposite what, guys? The largest side, which is 10, okay? So if 10's the largest side, the angle opposite it should be the largest angle. Do you guys agree? So using that same logic, what would be the smallest side, guys? Or excuse me, the smallest angle? angle B, okay? Because it's opposite the 6. So angle B would be the smallest. Questions on that? Okay. Name the longest and the shortest side in this example. But we're only given 2 angles. Yeah? The longest side is IT. I agree with that. Why? Its obtuse angle, which is 105, is opposite the IT. Very good. Okay. Now, how can we figure out how to compare T and I? Because we don't know what T is. Juliet? Good. Why am I adding those two together? Very good. Then I can subtract it from 180 and get that missing angle. Perfect. So I should get 151 here. And then I'm going to take that 151. I'm going to do 180 minus 151, which would give me 29. So I know that T has to be 29 degrees. So which of the 3 is my smallest angle? The 29, right? So T. Go across. What side is across from the smallest angle? IJ must be my smallest side. Does that make sense to everyone? Are there any questions? Ask me now. All right. Next one. Complete with a less than symbol, an equal to symbol, or a greater than symbol. If we're given that ABC is a right triangle with the measure of angle C being 90 degrees, what do you think I should do first? Draw a picture, okay? Draw a right triangle. Very good, Mario. One angle needs to be 90, so put a 90-degree mark. And it needs to be what letter? C. Does it matter where A and B go? No, as long as they're over here and over here, you can reverse the order, but make sure that A and B are not your 90, okay? How does the measure of angle C compare to the measure of angle A? It's greater. Why? Why, Daniel?
Because if it's a right triangle, nothing can be greater than 90.
But why couldn't A and C both be 90? Why couldn't they just be equal?
Because it has to equal to 180.
Okay.
And 90 is half of it. And
Why couldn't angle A also be 90 degrees here? Juliet? Very good. Then there's no room for angle B to be anything, right? And angle B has to exist because it's a triangle. Do you guys agree? Okay, so at most, it could be like 89.9, right? But that means that angle B is still 0.1 degrees. So angle C has to be larger than angle A. What about angle C compared to angle A plus angle B? They must be equal to each other. Because angle C is how much? 90 degrees. So how many more degrees do we have to deal with? 90. So do you agree that they're both going to be 90? Very good. So they have to be equal to each other. And the last one. How would AC compare to AB? Mario? It's less than. Why? Very good. C is the largest angle and opposite C is AB. So that must be the longest side. Okay? It must be larger than any of the other sides. Questions on this one? Okay, moving on. Example 3. This is where we use the inequality, the triangle inequality theorem, okay? The lengths of 2 sides of a triangle are 8 and 13. Then the length of the third side must be between what 2 values, okay? So to find the lower limit, guys, okay, you always subtract. And to find the larger limit, you always add them together, okay? So if you take 13 minus 8, what do you get? 5. So that third side must be bigger than 5, because if it's smaller, then you cannot create a triangle. And if you added them, you would get 13 plus 8 gives you 21. It must be smaller than 21. Because if it was bigger than 21, then it would not satisfy the triangle inequality theorem, okay? I would also like you to write, a lot of the times you're going to see your answer as 5 being less than x, which is less than 21, okay? X representing that third side. It needs to be between 5 and 21. Okay? So subtract to find the lower limit, add to find the higher limit if you're given two sides of a triangle, okay? So x can be any value between 5 and 21. Yeah, Hannah? Yes, okay? So the next problem says a triangle has one side of 14 and another side of 9, okay? Describe the possible lengths of the third side. So put x in the middle. It's going to have a lower limit and an upper limit. How would I find the lower limit? Subtract. So I do 14 minus 9, which gives me 5. So it needs to be between 5 and... How do I find the upper one? Add them. So do 14 plus 9. You'll get what? 23. So it has to be between 5 and 23. Now, guys, could the third side be 5 units? No. Why not? Has to be bigger than 5, okay? Could it be 23 units? No, it has to be smaller than 23, okay? In order to create a triangle. Last example, okay? I'm going to do 2 of these, and then the rest is on you guys, okay? In order to determine whether 3 lengths are possible for a triangle, okay? You add the 2 smallest sides. Add 2 smallest. And compare to the biggest. Okay? So, take a look at letter A. Of 6, 8, and 10, which 2 are the smallest? 6 and 8. If I were to add 6 and 8 together, it would need to be larger than 10. Is this true? What's 6 plus 8? 14. Is 14 larger than 10? Bingo. So that one works. For B, you would have added 3 and 4. Do 3 plus 4 total something that's larger than 8? You get 7 is larger than 8. And you guys agree that's not true? Therefore, those 3 lengths could not create a triangle. This is where we're going to stop, guys. Turn in your notes before you leave. Big Ideas is due tomorrow.
Okay, so we would follow this same procedure by adding the 2 smallest sides and comparing it to the largest. And for C, 2.5 plus 4.1 would be 6.6. That is bigger than 5.0, so it'll work for C. D, you would add 4 and you would add 2 and you would get 6. Guys, 6 is not bigger than 6, so this one does not work. And then lastly for E, remember, you can pick either of the 2 sides if there's a tie for which one's going to be larger. So we would pick 6 and 5. Adding those together would be 11. 11 is definitely better than 6, so that one works. So this is how you're checking whether 3 possible side lengths can be a triangle or not. You use the triangle inequality theorem. All right, lastly, I would like you to write down what was the muddiest part of the lesson, what was the most difficult to understand. Go ahead and write that down and then get these notes submitted.